Hello and welcome to this video on moles and molar mass. So the first thing we need to do is take a look at what is a mole. And so a mole is a quantity of substance, and that particular mole, if we're talking about quantities of substances, a lot of times we have these names. So for example, a dozen is 12 pieces. Well, for a mole is 6.022 times 10 to the 23rd pieces, and that's a number that we call Avogadro's number. And when we're looking at this, the number of pieces that we could have in chemistry, we can have these pieces represent individual atoms. We can have them represent formula units if we're talking about ionic substances, or molecules if we're talking about covalent substances. And so with that, we can actually use moles for a lot of different purposes, and one of them is we start off with doing these molar masses because we can do a lot with molar mass. And so for one given atom, if we're looking at individual atoms or elements, the atomic mass of that particular element in grams per mole is going to be the molar mass. Okay, so when we're talking about individual atoms, it would be the atomic mass unit, and when we talk about a mole, then it's going to be grams per mole. So for example, Fe, which is iron, if you look on the periodic table, it is 55.85 grams per mole. Okay, so atomic mass units if it's an individual atom, but if it's a mole, it's going to be that in grams per mole. Now, I will tell you that I tend to be a little bit lazy when I do my calculations a lot of times, especially in first year chemistry, and you'll find that I oftentimes am going to round these values to the whole number. And so if I were to round iron to the whole number, I would just round that to 56 grams per mole. Okay. If I'm working on labs or things that need to be a little bit more precise, if I'm working on AP chemistry, then I tend to use some place values right at the decimal. But otherwise, I like to do that. Let's take another example. So for example, nitrogen on the periodic table is 14.01 grams per mole. So of course, I just round that to 14 grams per mole. Now, I think the one that's a little bit trickier for me is chlorine. So chlorine is actually 35.45 grams per mole. I like to actually round this to 35.5 personally, but just to kind of keep things consistent with rounding to the whole number, this would actually be 35 grams per mole. And so you can see where if we're doing lab, we might want to have a little more precision in those values and use the actual data values that come off the periodic table, which usually rounds most things to the hundredths place. And so you can look on the periodic table, all of these values are on here. Here was the value for iron, is right here. It's not a highlighter. Chlorine, nitrogen, and so on and so forth. So all of these periodic tables will have something like that. Now, when it comes to doing this for a compound or a molecule, we actually have to do a little bit more. And so for 1 mole of a compound or a molecule, it's the sum of all atoms and their masses, and so we have to multiply by the number of each atom, so that's subscript, by its molar mass. And then we have to add all of those up to find the total products. And we're going to do this for a few different substances. So let's try these. So the first one I'm going to do is going to be Na2S, sodium sulfide. Okay. And so I know that I have 2 sodium, so I have to do 2 times the mass of sodium plus the mass of sulfur. And that's going to give me my molar mass. So let's go ahead and do that. So 2 times sodium on the periodic table is 22.99, I think, on my table. And so I just round that to 23 grams plus 32 grams, or grams per mole. I usually just write grams when I'm doing this. And so when I added all of those up earlier, I got 78 grams per mole. Okay, that is the molar mass for sodium sulfide. Let's try another one. So let's try a molecule. So C2H4. So again, we're going to have 2 times the mass of carbon, which is 12 grams, plus we're going to have 4 times the mass of hydrogen, which is 1 gram. Okay, and so I go ahead and do the math on those. So 2 times 12 gives me 24, 4 times 1 gives me 4, 24 plus 4 gives me a total of 28 grams per mole. We do this so much in chemistry for so many different reasons that it kind of starts to become automatic. So at first we have to work really hard at these, and then hopefully after a while it becomes a little more just automatic for you. Let's do one more. Let's do something like lead nitrate. Lead 2 nitrate. Okay. So with lead is 207 grams. Okay, so that is for lead. And then we have to take a look, and with this we have to distribute this 2. So this 2 gets distributed, so we multiply it by the 1 nitrogen. And so when we look at nitrogen, it's going to be 2 times the mass of nitrogen, which we said earlier was 14 grams per mole. Okay. And then finally for oxygen, it has to be 6 times oxygen. Okay, so nitrogen is 2 total in this molecule, and then oxygen we have to do 2 times 3. Oops, my 3 is a little goofy there. There we go. 2 times 3, which is going to give us a total of 6. And so we will add 6 times the mass of oxygen, which is 16 grams per mole. And then I go ahead and add all of these up. Be careful with order of operation in your calculators. 331 grams per mole. I would show you the calculations, but I can't dual screen multitask when I'm doing a recording like this. I hope that's helpful for you, and we will take a look at more examples of these in class, and we will be continuing to use these throughout the remainder of the school year.